All right, let us get started here on Lecture 7. Um, you'll notice that this is Data Types Part 2 because we didn't actually end up getting around to the Data Types part of the Data Types lecture last time. So we are, in one sense, a little behind, but like I said, we've built in a lot of buffer time where we have a lot of topics that we could get into, but we don't need to get into. So I think we're still doing fine in terms of time. So actually, instead of try to pack things in too much, I think we'll just sort of finish up this week what we were intending to finish up, or what I kind of thought about finishing up last week, and then just go from there. So I just wanted to point out this comic briefly before we go on. So I know this is not like exactly a realistic example, but this is a very computer programmery type thing to do, is to try to develop systems to do things that are relatively simple. And the one thing I just wanted to point out about this comic, although it's for humorous effect, this is the kind of choice that you'll be faced with a lot of the time in your academic life and so forth, whether to do things like sort of the somewhat easy but time-intensive way, like copying and pasting, information from 100 different text files into Excel and doing a bunch of stuff by hand, or putting in a little bit of mental effort and developing a system to do it, like a program to do it, for example, in Python, to do it for you. So, this is a trade-off that you guys, if you stick with this whole programming thing, this is a trade-off that you'll find yourself doing all the time. You're like, should I just do this by hand the way I know to do it, or should I really think about developing a system to do it? And time-wise, what you often find is that you spend, I've talked about this with friends of mine that are the same way, and you often spend 2 hours developing a system to do something and debugging it for something that would have taken you 2 hours and 15 minutes to do by hand. So you're not always saving a ton of time, but what you'll find is that if you start putting in the time now to learn things like programming and to learn these kinds of technical skills, the payoff is not always immediate in each task that you do, but the cumulative payoff is really big. So, the more stuff the faster things go. So over the course of 10 years, if you don't always take the easy route to not learn something when you could have taken the opportunity to learn something new and develop a new system, I think you'll find once you're a real whiz at this stuff, a lot of things become really, really easy. And I think I've said before the example of my old lab mate who would spend weeks balancing word stimuli for her studies, trying to counterbalance them just right so that the words in her lists didn't significantly differ from each other on all kinds of attributes. And she would do this just by creating these lists in Excel and randomizing a bunch of things and then trying to copy and paste words in different areas. And I wrote a script in about 2 hours sitting at a coffee shop that did this process in a few minutes once the script was done. So on the upside, it didn't take me 3 weeks to do my stimulus lists running a similar sort of task. On the downside, it had taken me 8 years to develop my programming skills to the point where I could do that. So it's sort of hard to see the immediate payoff, but I think it is worthwhile in your life if you think about doing things the arbitrary condiments way instead of the sort of straightforward way sometimes. Not always. I mean, this is sort of the ridiculous case. But anyway, that's the little moral of that comic, I think. All right, so like I said, topics-wise, we're still actually kind of stuck on last week's topic, but that's okay. What this means is I know we'll get for sure to keyboard input and timing, which of course is something really critical for you guys to learn if you're going to do any sort of cognitive tasks for your projects. And also reading and writing out files, which again I left till the end because it's a little bit tricky, but it's also really essential because obviously a lot of the advantage if you're designing a cognitive task of doing it in something like Python is you can give your task like an Excel file or a text file with all your stimuli listed in it and just tell your program to read that stimulus list from the file and use these stimuli in your experiment, right? And because, what you're probably doing when you're designing experiments is making lists of stimuli in Excel or something like that anyway. It's nice if you can just program the computer to read in files. And then what's super nice is you can then program your task to write out the data from your task, reaction times and accuracy and things like that, to write it out in a format that's easy to analyze. So, one giant advantage that you'll find if you learn to program and do your tasks this way is that analysis becomes like super easy because you don't spend all this time copying and pasting things into Excel files necessarily. You can just have your task itself analyze the data as you're collecting it and just basically spit out a result. So anyway, we'll look at reading and writing files. I'm not sure whether we'll get to these last two topics this semester or to what extent we'll get to them. But that's okay. That's kind of crazy advanced stuff anyway. So I really more prefer that we learn this stuff really solidly. And then if we have time, we can do some crazy advanced stuff, or we can do that during the catch-up days next semester if everything goes smoothly. So that's the plan for now is, just focus right now on doing these last three topics and doing them really well, and then see what we have time for at the end of the semester. Okay, in terms of administrative stuff, problem sets, I think we should have problem sets for everyone for problem set 3. That was due last night at midnight. Problem set 4, I haven't finished yet. I wanted to take another little look at how everyone kind of did on problem set 3 before. I haven't had time to formally mark it at all yet, but I wanted to take a quick look at how people are doing on problem set 3 and calibrate problem set 4 accordingly. But I think what we're going to do is I'll have it out tomorrow sometime, maybe during the day or maybe in the evening. And because next week is a holiday week, and I'm not expecting you guys to come in here and work on this stuff, we'll make it due Monday the 19th of November, which I think will give you enough like school days to work on it. If you also, I'm assuming you're not going to be completely just screwing around next week while we're off of class. So hopefully, if you have access to PsychoPy at home, or even if you don't, I think you'll have enough work days to work on this if we make it due on Monday the 19th of November. So, again, if it proves to be difficult, let me know. But I'm assuming most people probably have access to a computer they can play with PsychoPy on, even if we're not officially in class during that time. Okay. Hopefully, then that means I will also have problem set 3 back to you by the next class session. We can talk about that a bit. In terms of projects, I looked at the calendar, and I think the best due date for your proposal will be the 18th of December. That's the last week of class. Now, to be nice to you, I figured I could have made it due on the very last day of the semester, but I'm making it a few days earlier than that, just so if this is the last piece of work you have to do and you're procrastinating on it, even if you procrastinate, you'll still have a couple days left in that week to, not have to work on anything. So I'm trying to be kind to you by virtue of knowing that you'll probably procrastinate to make it due as late as possible while still forcing you to take a couple days off at the end of the week if you don't have any more classes after that. I think that's the Wednesday of that week. And of course, I think you'll have plenty of time to turn it in earlier, so if you want a longer vacation, that's sort of up to you. Okay. A couple other things I will mention on these topics. About problem set 4, it looked to me, problem set 3 was really focused on making sure you guys have the concepts of functions and the sound stuff down really well. But I think between last week's lecture and the problem set, that's pretty good and pretty straightforward. So I think you guys are really getting the mechanics of this stuff down pretty well. So problem set 4 is going to incorporate some stuff from class today, but it's also going to focus on not so much testing as many new topics, but testing your creativity and your ingenuity a little bit more. So most of the problem sets so far have had pretty straightforward questions to answer that are largely adapting code that we've already written and so forth. I'm hoping in problem set 4, I'm going to give you a few new problems that you have all of the core knowledge to answer, but you're going to need to actually have some insight to solve them. So you're going to need to figure some stuff out that we haven't explicitly talked about. So there's going to be a little bit more emphasis on problem solving and kind of figuring out things for yourself while not actually having to learn anything new about the Python language, just while having to solve novel problems with the knowledge you have. So that's going to be the emphasis. Okay, So, and again, I highly recommend if you have questions about your project proposals, come and talk to me. We can talk about like what a good level of complexity is to aim for in those projects. And again, the proposals don't have to be anything crazy. I just really want you to show that you are thinking and like making a good plan and thinking through the project well before you start it, which is sort of the point of any major project. Okay, and like I said, I can guarantee you'll know all about keyboard input and output and task timing and things like that, and reading and writing files. I can't guarantee the other stuff, but I think that should be plenty to come up with a cognitive task. Okay, any other questions or other stuff for the record or things people are wondering about? Everybody good? Okay, so I think what we're going to do is start with a demo this time. So if you remember last time, we finished up class with a really dumb little game, a really terrible, unfun game that is going to continue to be terrible and unfun, but will get a little bit more complicated at least today. So we're going to start off refreshing that and then develop it a little bit further before we go on to talk about data types. So with this stuff, if you want to follow along, you can. I uploaded, so you might have typed the code along last time with me, or you might not have, but either way, I uploaded a zip file with the code from last time into the Google Drive folder, so you should be able to find that. I forget exactly what it's called. It's called something like Lecture 6 code or something like that, .zip. So if you want to start where we left off last time, like I'm about to, and follow along, that's probably not the worst idea, although we won't be sticking with this demo too much longer before we move on to something else. Okay, so let's see. We started off last with, what did I call it? My Dumb Game or something like that. Okay, so if you remember back 1 week ago, we had this dumb little game that we're doing in text format just to illustrate this. Although I'm trying to get us away from doing text input because it's kind of weirdly tricky in PsychoPy. And remember we said I worked a little bit of magic here at the top, so you don't need to worry about these first 2 lines. But the first thing to note is that we're importing psychopy.sound, and we're doing this really basic thing where a really kind of lousy game, where if we execute it, exec file mydumbgame.py, it first says I encounter some sort of dragon and asks if I want to fight or flee. And if I say flee, I get away safely. Oops, that window is too big, isn't it? All right, there we go. But if I tell it to fight, or actually if I tell it to do anything else, all right, so you get the little death march and you died. Okay? All right, so bad news for fighting the dragon. That's apparently not a good strategy in this game. And hopefully you guys got some practice doing this yourselves in the problem set. It looked like most people had good functions for playing Twinkle Twinkle Little Star, so congratulations there. Okay, so let's keep up with this. Again, this game is not going to get much more fun to play, but it is going to get, we're going to add a few layers to it. So obviously the game is not going to be very interesting if the only thing you do is encounter a dragon and fight it. So, if you're still alive after you fight the dragon, maybe we'll add some other challenges to this list. So what I'm actually going to do, hopefully by now with your experience, this should strike you as a really awful way to do what we're doing here, but this is what we're going to do for illustrative purposes. All right, so I'm going to copy and paste all that code, and let's say the next thing you encounter after the dragon, let's say we encounter an orc next. All right, so you encounter an orc, fight or flee, and unfortunately the game's not going to get much more fun because the answer is still the same, that if you try to fight the orc, you're going to die again. Whoops. So let's do the exec file thing. Oh no, sorry. Escape. Copy and paste that exec file line. All right, so let's flee from the dragon. Oh, we got away, yay. Let's see, should we fight the orc? Let's try to fight him. Oh no, look, we died again. Okay, so again, not very fun, right? Every time you fight, you die, but that's fine and all. But let's just for the sake of illustration, let's put one more obstacle in the player's way before we change up this dumb example here. So let's say, let's say you encounter one of the lecturers early in the morning before he or she has had his or her coffee. They look angry. All right, so third obstacle, probably the most fearsome of all. This is the boss fight. So play this game, you encounter a dragon, we'll run away from the dragon. Encounter an orc, we'll run away from the orc. I think we can beat the lecturer, right? Should we fight? Oh no, look, died again. Okay. And then if you want, you could add some little code at the end, little ending thing. So you could say something like, if player is alive at the end. Remember we had this Boolean value, player alive. If you live, it stays true. If you die, at the end of the death march, we set it to false. And maybe you could say something like, print, congratulations. You beat this terrible game. Okay? Oops. Oh, you know what? I disobeyed my own advice. Let's use single quotes here. Okay. And otherwise, you could say something like print, sorry you lose. Did you not know that cowards always win? At least in this game. All right, so there we go. So we don't have to run it again. You can see, though, that if we get to the end of the game, we can run it. So let's flee. Congratulations, you beat this terrible game. Okay, so now we've got, from beginning to end, a really awful text-based adventure game, right? Where every time you fight, you lose, and every time you run away, you win. And the main point to make about this is this has the structure of a game, but as you can tell, it's already gotten really long, right? Because we have like 130 lines of code to do what is essentially a really stupid and straightforward thing, right? So you guys have probably, I think you actually had a problem like this, kind of like this on your homework. What would probably help, right, is that at the very least, we have a lot of really redundant code here, with all these play statements, right, to play the death march. So one thing that would be really nice to do is go back and make a function that plays this death march, right? Because then we could like reduce all these lines of code into just one. So let's make a new title, or a new file. Let's call it something like game functions.py or something like that. And then say from game functions import star. Now, hopefully, by now you guys should be pretty good at writing functions, so you should know, hopefully what we can do is take all this code that plays the death march and just cut that. Actually, we'll want to leave those tabs there. And we can go in here and say, we'll call it like death march. And paste that code right in there. Oh, we're going to have some indentation issues, so you might have to delete a bunch of indentions. Oops. I think I accidentally hit page down. So once you do this, it's a little tedious. I think we said that you can unindent a whole block of code, but there was a little bug with the graphical interface in Psychopy to do that, so I'll just do it by hand quickly here. Okay. Almost done. Whoops. Okay, so we've got our death march function, right? So all we did is define a function called death march, and put our old code in there. So we should be able to just say death march, right, where we had all that code before, and we can replace all of this code with death march, and all of this code with death march. All right. Oops, I keep doing that. Forgetting I already copied and pasted. All right, so let's exec file that. Okay, so this is the first thing I screwed up. I semi-deliberately screwed that up. What did I forget to do here? What's that? Sorry. Oh, okay, so that is something I did, but that's actually not the issue that I'm running into in the syntax error. Anybody else see what I forgot to do? So it's on the line, it's a syntax error on the line def death march. See that? Where's the arrow pointing? What am you guys are making hand gestures. Does that mean what I think it means? Is that these? I think I'm missing some parentheses or some brackets, right? So let's see if that works now. Okay, so remember that, I can't remember, you guys did some functions in the problem set that didn't have any parameters, right? Or did you not? I can't actually remember. Oh, okay, so this is new actually. So even if the function has no parameters that you're passing in, you still need the parentheses to indicate that it's a function, okay? So that's one thing worth noting. I think you might have figured that out if you would try to do this in your own life and had this error. But yeah, so one issue you're going to have is that you'll need to remember to put those parentheses in. Even if there's nothing to go inside them, those parentheses kind of mean that's a function and not some other name. Okay, so that works. Let's see what happens if we try to fight the dragon. Okay. So now we run into this global name psychopy is not defined, and as you guys correctly pointed out, I don't need the import psychopy sound actually in the game file anymore because it doesn't directly play any sound. We can put the import psychopy.sound into the game functions file. Let's save all that. Did I save those? Save. Whoops. And try that exec file thing again. Whoops. Oh, that's interesting. Let me just try something. Oh, I might have. Huh. That should actually work, I think. Let me just see if I forgot anything weird. It should work, I think. Worked in my test code. All right, anybody see anything I'm missing? Import psychopy.sound. Global name psychopy is not defined. Oh wait, that's weird. Line 4 in death march. Okay, yeah. Import psychopy.sound. Let me actually just try. I might be having these weird issues. No, that shouldn't happen, actually. Nobody else sees any particular... This is actually kind of stumping me. It should actually... This worked when I did this before. All right, well, we may be... Just try something. This is sort of advanced, so let's see if this works. No. Global name. Psychopy is not defined. Oh! I think I see. I think I need to also do this. This is debugging in real time, guys. Let's see. Oh no, actually it's not. Well, this might impede our progress unless I can figure this out. Psychopath. Sound, Psychopath core. Traceback input, line 1 module, file item, game.py, line 11. Is the death march function. Line 4 in death march is s.psychopath.sound.sound. Game functions. Anybody else have any bright ideas here? Psycho. Hi. All right, well, let's just try something for grins. Because I think this is actually kind of an issue of, again, this recurring issue we keep having with the PsychoPy shell. Let's just do this. So what I'm doing here is actually putting those function definitions into this code, and let's try that. Okay, so that works. We weren't doing anything particularly wrong. This is weird. So, okay, on my own time, I will have to go figure out why this was not working when it was in gamefunctions.py, because it was totally working. It was totally working before, especially when we did the functions demo and the psychophysics demo, right? Because we did some functions before. Yeah. Oh well. Let me try actually one other thing. Let's before we totally give this up. Let's try one other thing that we might be able to fix. Import psychopy.sound. Import psychopy.core. Let's get rid of this death march and see if that works. Welcome to a life of programming where you sometimes, even if you think you understand everything, have to tweak things in weird ways. All right, so let's see if taking that out kills that. Okay. Weird voodoo, right? Because do we do something? I don't know. All right. Anyway, it seems to work now, right? We're going to run into some weird issues, like I said, when we use this shell to do text-based stuff, which is one of the many reasons I am trying to get us away from doing text-based stuff in the shell, because for some reason it doesn't work as well as stuff you run using the little Running Man icon, which runs in like PsychoPy function mode, where you're displaying text on the screen with like drawing functions. So again, this is sort of a problem, I think, of trying to do a weird mix of text-based stuff with PsychoPy sound functions. So I think that's what's going on. But anyway, all right, so that's proof that this does actually work the way I intended, right? And anyway, the advantage of that, if all right, so the advantage of that, if I put it like this, so actually, let's try that one more time and make sure it still works. Oh, what happened? How did it stop working? So all I did was take out that stuff. What? Oh, this is just crazy talk. Okay, PsychoPy is messing with my head now. All right, well, anyway, spent too much time on this. So Anyway, the point is, this should in theory work. I'm not quite sure what issues we're having here. So let's try one more thing. Oh, all right. Oh, now it comes in line. Okay, well, anyway. The point being, in theory, if this had worked, is we've gone from like 130 lines of code to like 30 lines of code, right? Because, oh! Was that the issue? I had def underscore. I didn't have that fully typed. Sometimes you get weird errors in CyclePy that... No? Oh, it's going to drive me nuts, guys, because this totally worked. I typed out the example code. Okay, well, anyway, so much for that. The point being, if you use functions, even if your functions don't have any inputs or return any outputs, right? Because the def march function does not actually produce any data as an output, and it doesn't actually take any data as input, right? Everything it does is self-contained within the function, but it does save you a lot of code, and that in turn makes it much easier to read this code, right? It's much easier to see the structure of this task, or not this task, but this game, if you only have 30 lines of code to look through, and it's pretty straightforward, right? Okay, so that's that. One thing I'm going to do, I think, is just close those both down. Oops. I think we're having all kinds of issues with CyclePy wanting to misbehave today. Let's see if we can... Yeah, I think we're just having an angry day for CyclePy. Maybe I should actually click that update button at some point when it asks me to update. Okay, so let's try opening again. mydumbgame.py now, and open up gamefunctions.py. And I'm going to do one other thing just to check this one last time, because the rest of the demos kind of depend on this. I'm going to delete those PyO files just in case it's getting confused. So this should work in theory. Let's try it out. Okay, so let's go over to the shell. All right, that's exactly what I was supposed to do all along. I don't know why I was confused, but I think something in CyclePy had crashed somewhere and was trying to run an old version of the file. Okay, so now we're back. I'm not an idiot, hopefully. Hopefully this all works as planned. Same code is now running that was not running before. That's fine. That's just CyclePy being weird. All right, whatever. Okay, so point made, a little bit slower than I'd hoped. Right, you can save a lot of lines of code, which in turn makes things easier to read what you're doing and understand the structure of the code, which in turn is going to make things faster for you actually developing this code, right? So the whole point of this exercise is just to show you using these functions and thinking about the structure of things and trying to eliminate redundancy in your code will actually save you a lot of time. Now, we can still actually eliminate a lot of redundancy in this code, but for that we're going to have to go to our next topic of the day, which is actually data structures or data types in Python. So the whole point was really to get us to this point where we can talk a little bit about data types in Python. Okay? So, a couple valuable lessons there, not the least of which is when in doubt, quit CyclePy, clear everything out, and restart it, because maybe you're not being an idiot, maybe CyclePy is just being a little erratic. Okay, so if you can remember back to Lecture 2, we first brought up the idea of data types in Lecture 2 when we talked about different types of variables, right? And back then we said, for right now we're only worrying about integers, text, or as you now know they're called strings, and Boolean values, which can be either true or false, right? Now, one thing to keep in mind in this discussion is that when we talk about these data types, this is just a conceptual thing that we've invented to help our puny human minds deal with these concepts of computer programming, right? So Bender is happy. You guys watch Futurama? You guys know the show? Bender is celebrating here because he is awesome, and he does not share our puny human minds. He sees the world of data as it really is. It doesn't make any distinction between numbers and text and pictures. Everything inside the computer, of course, is just ones and zeros, right? So when we say you have an integer variable or you have a string variable or whatever, you have to keep in mind that in the actual computer memory, right, it's not in there in a really tiny print. You don't have little text written, and you don't have little numbers, right, and you don't have little true-false values. What you've got inside the memory chip in your computer, if you zoom in on some incredibly tiny piece of each chip, is you've got a bunch of bits, right? And you don't have to worry about in silicon how the bits are actually made in hardware, but you've got a bunch of bits which can either be ones or zeros, right? And these ones and zeros, of course, aren't even really ones and zeros. What they really mean is in some little piece of silicon on one tiny bit of the RAM chip, a voltage is either high or low. And that's really what a 1 or a 0 is. But what we do is we basically say, all right, high voltages we're going to call 1s, and low voltages we're going to call 0s. And for our convenience, mostly, we're going to package these bits together in 8-bit chunks that we call bytes, right? And the fact that we use 8 is kind of arbitrary, right? But we tend to group them into 8 bits at a time, because 1 bit of information doesn't tell you very much. So you group them into 8 bits at a time, and you have things like this, right? And you can interpret these bits being on or off, or ones or zeros, in a lot of different ways, right? So one way to interpret this is as numbers. So you could imagine all of these bytes of information, in this tiny little chunk of computer memory as being a 72, followed by a 101, followed by a 108, and so forth, right? And that's just by translating, if you guys remember back to mathematics class when you probably at some point talked about base systems, right? Using base 10 versus base 8 versus base 2 or whatever. Calling it 72 in decimal is the same as 01001000 in binary, right? So the point is, when we say we've got an integer, what we really mean, if we say you've got the integer 72 stored in a variable, what you really mean is you have the binary value 01001000 stored in some byte in memory somewhere. And of course, even these decimal numbers might be interpreted in different ways, right? So these decimal numbers might really represent the string hello world or something like that, right? Because what that means is in what's called ASCII code, when you say I want to store the string hello world in memory somewhere, it's really just a series of numbers that some part of the computer is interpreting as a string, right? Does that kind of make sense to you guys? So really everything boils down to a number representation, whether it's supposed to represent a number or whether it's supposed to represent text or whatever. And these same pieces of information could also be used to represent, for example, pixel values or brightnesses, right? So if you had a grayscale picture, you might also say, well, actually this string of bytes represents a list of pixel brightnesses, right? So like 72 is kind of dark, 111 is pretty bright, 44 is kind of dark, 32 is kind of dark, 33 is pretty dark, 100 is kind of in the middle, etc., right? So the point of this is keeping in mind that what we call data types is just a human conception, right? The same list of bytes in the computer memory could be interpreted as the number 72, 101, 108, etc., could be interpreted as the phrase hello world, or it could be interpreted as a bunch of pixel values in a picture, right? Does that make sense to everybody? So, you don't really have to know that exactly to program, but it's important to keep in mind that there's nothing magical about a certain data type in a programming language. It's just something the programming language makes available to you as a convenience so that you don't have to be constantly converting text strings into binary for the computer to process, right? So you can just think of it in terms of text, which is the natural way that you would think of this stuff, right? Any questions about that? Does that kind of make sense to people? So the reason that's important, it's not important to actually know how different types of data are represented in Python, right? If you ever get into really low-level programming, doing like crazy programming for like games that have to run at 85 frames a second or whatever, Then you get into the real details of like how many bytes long a different data type is and so forth. You don't have to know all that stuff in Python. The main point is just to remember that these are not hardwired into your computer. The only parts that are in the computer wiring are just bytes. The data types are a feature of the programming language you're using, which means that next semester when we do MATLAB, you'll find it actually represents data somewhat differently. So the way you choose to represent data depends on the programming language, right? So most programming languages have a lot of things in common. Most programming languages have a way to represent integers and a way to represent text and so forth. But when you get to talking about more complex data structures, it really depends on what language you're using, what type of data you have available to work with. So, because MATLAB is primarily a scientific computing program, like it's mostly about processing large amounts of data, right? MATLAB, you'll see, has a lot of functions available for processing like matrices of numbers, right? Which Python can do, but it's not like the built-in way of treating data, right? So anyway, that's all just to say that keeping in mind this is just how Python chooses to let you represent your data. There are other ways of representing data that are not the way Python chooses to do it. So you already know about integers. We've used a lot of integers so far. You already know about strings. You already know about Boolean values. We've also talked about a couple of other things that are basically data types, like objects, because we've talked about windows and circles and images, and what objects are in Python, and they are a type of data, effectively. And we've also touched on, although we haven't explicitly talked about it, what we call floating point values. And floating point values are really just decimal values, okay? So we can go back into CyclePy to talk about this a little bit. So remember back when we were first doing our really dumb number guessing game, you would do things like this. So if you say a equals 5, you can create a variable named a that represents 5, right? If you want to see what a is, you type it in and it's 5. What am I going to get if I say a divided by 2? Who remembers what we're going to get as the answer of this? Okay, I think I hear people saying you'll get 2, right? A divided by 2 is 2. All right, that is correct, right? And of course, that's not the right answer. How could we rephrase that if we want to get the true mathematical answer for 5 divided by 2? Okay, so we change the 2 to a 2.0. You guys remember that? And we get 2.5, right? Okay, so what we're really doing here, this is to illustrate two things. So Python represents integers. So the integers and decimal values are both numbers, right? And we don't really make a distinction between them in everyday life, right? Usually in our minds we just say, well, you didn't write 5 point anything when you wrote it, so you must mean exactly 5, the integer, right? But Python actually has different representations for integers versus what are called floating point values. And floating point just means the point is the decimal point. Floating means the decimal can be anywhere in there. So there's a reason it's called floating point. It's not really important. The main point of it is that you can have numbers as big as you like. So if you wanted a to be 5 and b to be point, whatever, that's fine, right? Python, now it will actually round it off at some point, but you can have as many decimal places as you like in something. It's just going to round it at some point because it can only represent it with a certain degree of precision. So the point is, if you go with a somewhat more realistic number like this, you get something like this, right? So you see there's a little bit of precision error with floating point numbers with a lot of decimals, but you can put the decimal wherever you want to. And anyway, that's why it's called floating point, is because the decimal could be early in the number, so you could have like b equals 45 or 46 point, right? Or b, so that's b. And again, you get some rounding error here. Or b could equal, a bunch of things, followed by just 2 decimal places, right? And, so anyway, the decimal point can move around, right? But the point is, floating point values have a point in them, a decimal point. That's hence the name. And they're different from integers, okay? So the way Python, one other thing to illustrate about this is both of them behave mathematically the way you would expect them to, with the exception that integers, if you do a mathematical computation with integers that results in some decimal point, right? So if you say what's 5 divided by 2, you get 2, right? So Python's way of dealing with doing a mathematical operation with two integers that produces a non-integer result is just to lop off everything that is not part of the integer answer, right? So if you said 5 over 2, you get 2. If you said 7 over 2, you get 3, right? Because 5 divided by 2 is 2.5, 7 divided by 2 is 3.5, so it just lops off the 1/2, and you end up with the integer part of the answer, right? So the thing to point out here is just mainly that Python does not require you to explicitly say when a variable is an integer or a floating point value. You just have to tell Python that via context, right? So if I tell you that a number is 5, to you and your human brain, it doesn't, and I then say divide it by 2, you have no problem taking two integers and dividing them and coming up with a floating point value, right? But Python, if it sees two integers being worked with, it wants to give you an integer output. So if you want something that has an integer value like 2 to be interpreted as a floating point value, you have to say like 2.0, right? So if you say 7 divided by 2.0, that's fine. If you say c equals 2.0, and what's 7 divided by c, it gives you 3.5, right? So the basic point here is Python has something it's called implicit typing. All this means is, in some programming languages, if you invent a variable called like c, you have to explicitly tell the programming language, here is a variable I want to create called c, and I want c to be an integer and to represent only integer values. Or I want c to be a floating point value and only represent floating point numbers. In Python, it depends on how you define it, what type it is, right? So if you give the value assigned to c some decimal points, even if it's 2.0, it treats c as a decimal or a floating point number from then on until you assign it a value that's an integer, and then c can become an integer, okay? But Python, you don't ever have to explicitly tell Python that, it's just how you use the number. Does that kind of make sense to everybody? Everybody get the idea here? This is just to remind you that these two things are different and that you can get into trouble sometimes, right? If you think the human way and say, all right, 5 divided by 2, that's 2.5, and Python rounds that off to 2, that might make a big difference if you're trying to place stimuli on the screen, whether it's 2 times a certain radius or 2.5 times a certain radius that you're trying to go to, right? So anyway, so for the most part, even though we haven't explicitly discussed floating point values, you know how to do things with them, right? You already know all the major operations you can do with floating point values and integers and so forth, like add them, subtract them, multiply them, divide them, and so on, right? So that's not too big of a deal. So anyway, those are the main points to make about floating point values. Hopefully that all makes sense. So the big stuff about Python that is new to learn, well, there are two main things about Python that are sort of unique. So all those other data types are pretty much in most programming languages. Most programming languages have a way to represent integers, floating point numbers, strings, and Boolean values. But one thing that's different about Python is even the most basic data types, like integers, can actually be treated like objects, right? So we said objects were one data type, but that's not exactly true, because actually in Python, all variables are objects in a sense. So this is different. So in MATLAB or C++, the difference is this. Numbers in MATLAB or a language like C or C++ are only numbers. Like if you have a number like 7 doesn't do anything, right? 7's just a concept. 7's just information. 7 can't go out and do things like toasters or cars can, right? Does that kind of make sense? It's just information. You can do stuff to information. You can take information, transform it into other information, and so forth, but information doesn't do things, right? In Python, that's different. Data, like integers and floating point values and strings, can do stuff. You can treat them like objects and have methods associated with them. So actually, this is not particularly interesting for numeric data types, but you can do some interesting stuff with strings, so it's worth showing you some of these things. So, for example, and you might want to play along with these as we go, like on your own. copy of CyclePy here. So if we have a number like, let's just say 5, for example, and we try to do, so we said a equals 5, right? So a is an integer. But if we treat a like an object and say a dot something like this, we can see that these methods pop up. So a actually has some methods. We don't need to worry about all these weird ones with underscores. But it has things like conjugate, denominator, imag, numerator, and real. Like we said, well, for decimal numbers, these aren't really actually that interesting because I don't think you guys will ever have occasion. It has some various functions to deal with like imaginary numbers and so forth, but you guys probably are not going to be using imaginary numbers in this class. So, oh shoot. So that's a little outside of what your usage would be. But if we say like, well, let's see if the floating points have anything more interesting. Floating points can do a few more interesting things, like a floating point number can tell you if it's actually an integer, which it actually is, right? If I said a equals 5.0, a dot is integer is true, whereas if I say a equals 4.9, a dot is integer is false. So that's kind of interesting, right? But not that interesting. So a more interesting thing to do is maybe to say a equals, this is a sentence. And if you do this, you'll see that strings actually have a bunch of possible methods you can use. And some of these do things that you might find pretty interesting sometimes. Like, let's do something like a dot, there's a lot of them, right? A dot upper. What do you guys think this is going to do if we do a dot upper? Yes, it turns it into uppercase letters, right? And if we say b equals a dot upper, we can of course, whoops, a dot up, b equals a dot upper. We can have b that is the uppercase version of a, right? So that you can see how that might be useful sometimes. But if you know, or conversely, if somebody's just shouting at you on the internet and you say, you have them say, this is a sentence, you might want to say something like b dot title. Maybe you want something more like that turns it into title case, right? Or the opposite of b dot upper would be b dot lower, which turns it back to lowercase, right? And I think there's also, let's see, I think there's, yeah, we've also got b dot capitalize, right, which is just capitalizes the first letter of everything and nothing else. So that's all interesting. You can do a few other things like center text. Oops. So if we call b dot center, you'll see an error because we need at least an argument. And if you do something like b dot center 40, what does b dot center 40 look like it does? It produces a string that looks like this. Well, what if I do b dot center 30? What do you guys think is going on here? Yeah, exactly. So it centers whatever string you give it in a space that many characters wide, right? So this right here is 40 characters wide. This here is 30 characters wide. And so what it's giving you is a centered version of a string with spaces around it, right? And again, you may or may not ever find this useful. You could in some circumstances, right? You might want to center some text. If you have like an 80 character wide window, and you want to put a bunch of instructions in that are all centered, you could do it that way. But the main point to note is just that you have all these methods that strings can actually do stuff to itself, right? And you can even, this is something that if you do real programming, you find yourself doing all the time. You do things like find. So let's say b.find is, or let's do b.find sent. What do you think, if this is b, what do you think this, that's interesting. I actually kind of discovered a bug in my logic while doing this. What do you think this find function is actually doing? Do another one. Find. Oops. That gives you 14. All right, so what is b.find doing? Well, what does the name find suggest that it's doing? It's find, okay, so it's like the find function when you hit like Control F in Microsoft Word, right? So I'm trying to find, what it's doing is it's searching within B, right? Because B itself is, this is a sentence in all capital letters, right? So if you do b.find sent, it gives you 10. What do you think that 10 means? Yeah, it's the 10th, and it's actually going to probably, if I'm getting this right, it should be the 11th. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so it's where that text begins if it exists in the string, but it starts with 0. So if it gives you 10, it's actually the 11th character in. You know what I mean? You guys have seen this before in your problem sets. Numbering in these things starts with 0, not with 1. So that's a little tricky thing, but yeah, it gives you the position of what we call the substring, or the thing that you're looking for within that string. So you can see that might be really useful, right? Because if you have some file named like, my data file dot subject, 0, 1, 2, 3, dot accuracy dot text or something like that, right? And if maybe you don't know exactly how long the file name is, but you know all the files have subject something in them, you can look for the substring subject, and you can figure out where the number of the subject probably begins, right, within the string. And then you can do stuff with that, like, get a number representing the subject number, and that might be useful to you. So anyway, this find function is really useful. But we don't need to get into the details. The point the main point to make here is that strings also have methods associated with them, as do all data types in Python, which is a unique thing about Python that's different from, say, MATLAB. Oh, there's one other thing. So we've actually already been using one method that strings have already. Does anybody remember a case in your homework or in the stuff we've done in class where we've used a method of a string before? Anybody remember this? Well, maybe this will jog your memory. So of course, what I've been doing things like b.find with a string variable called b, but we can also do these things with the string itself, right? So we could say like this is a sentence dot upper with the literal printed sentence and do the same thing, right? Anybody remember a case where we've done like a string followed by a dot and something else? All right, how about, yeah, so you guys remember format? This is sort of one of these weird little tricks that I said we're not going to worry about right now. So if we have a is equal to 5 and b is equal to this is a sentence, let's change b equals, let's say b is now going to be this is a number, colon, and we did this little weird trick where we had the curly brackets and a 0, and then we said dot format, and we can say like a. We get the string, this is a number, colon, 5, right? So we've been doing this trick all along. We didn't really talk about what it is, but what we're actually doing here is we're taking a string. Again, it doesn't matter whether the string is in a variable or whether the string is just a string that you type. And we're calling this function called format, or this method called format. And what we're doing when we call format is we basically are putting placeholders in the string surrounded by brackets, and then telling the format function to take whatever we put into format and replace the placeholders with that, right? So we could have something like first num equals 5, second num equals 3, and string equals, we could say, What else do I need to type in this to make this come out right? I need to type a third thing into the format method. Yeah, it's going to have to be first num times second num. And then my string is going to be 5 times 3 equals 15. Does that kind of make, does everyone sort of see how that works? So with this, again, you don't have to know the details. Like the format function can get kind of complicated. But what we've been basically doing all along with this funky notation is when calling this format method of a string, making a string with placeholders in it, and then telling the format method to replace those placeholders with whatever numbers we feed it. And you actually don't have to just use numbers. You could use other strings or something like that. But this is very useful, right? If you ever want to take a number that you have in your code and make a string out of it to do a string type thing with it, right? So for example, if you want to give feedback to your subject and say, your last response was X milliseconds, you have the number of milliseconds in a variable somewhere, you're going to need to make a string out of that number, right, to turn your number representation of the milliseconds into a string with the characters representing that number. Does that make sense to everybody, that distinction? That kind of semi-clear to everybody? Okay, so anyway, main points here. In Python, that all data types can be treated like objects. We've actually been using some of these methods of some of these simple data types already, and that if you want to do things with a string or something like that, a good idea is to look up what the methods of the string data type are, because you might have a built-in method for a string that actually already does the things that you want. So anyway, so that's the main point about major data types. So we'll take a break in just a second, but what I wanted to get through today is talking about not so much the built-in data types that we have already seen. We want to talk about a couple more special sorts of data types in Python. And this is in addition, there are all kinds of objects that you can import from modules, right? So we're not worrying about all the windows and the circles and the lines and the sounds and so forth. You can import from CyclePy modules. We're talking about built-in pieces of actual Python. A bunch of them a bunch of them exist that aren't worth worrying about for now. So we aren't going to talk about some of them, but two that are very useful but very similar to each other are worth using, and these are called lists and tuples. So I'll tell you about what lists and tuples are, and then maybe we'll take a little break, and then we'll come back and actually use them, okay? So lists and tuples are also a little bit different from what we've used before, because when we talked about integers and floating point values and strings and so forth, these are all like basic types of information, right? Numbers, text, whatever. Lists and tuples are not specific types of information. They're really containers for grouping together pieces of information, right? So the word list probably makes sense to you, right? A list is a list of other variables, basically, or a list of other values. And tuples are a very similar concept. They're just a little bit different. The good news for you is that if you confuse them, that's often okay because they can be used almost interchangeably. There's one critical difference between them. A list is mutable, meaning it can be changed. So that's like, think about your grocery list. You think, oh, I got some bread. All right, I can cross that off my grocery list, but I just remembered I need candy, so I'll put some candy on my list, right? So you can change lists all the time, right? I find whenever I go shopping in this country, I can never find the thing I want on the first trip. So I'm always like crossing 3 things out and going to the next place and crossing something out and adding another 2 things or whatever, right? But tuples, the main difference is tuples can't be changed once you create them. They're immutable, okay? Now, to you, you might say, well, what's the use of creating a data type that you can never change? But there are actually some contexts where they're very useful, where you want to create a tuple that can't be changed, like if you want to give a tuple to a function and want to make sure that it doesn't change your information, you could use a tuple, for example. But for the most part, you can use these 2 things pretty interchangeably. So in theory, there are a few situations where tuples might be preferable. In practice, you could pretty much get away with using lists exclusively in this class, so we will mostly stick to lists. The good news is, oftentimes so if you're doing something in Python where something is expecting to get a tuple and you give it a list, Python is pretty good about saying like, oh, I'll just turn this list into a tuple without really worrying about it. So that's fine. So mostly we can just use lists in this class, but it's worth knowing that there is a difference between them and to be aware of some conventions. So by convention, this is not a rule of the Python language, but it's mostly a practice that people follow. Lists are generally what you would use to group together similar items, and tuples are generally what you would use to group together different items. So what this means is a list might be, say I have 40 trials in my task that I'm doing. I might have a list of all the reaction times from all those trials. And what that, so that list is going to be 40, floating point values with a number of milliseconds or whatever, that all represent the same information, but it's a list of the same type of information, right? It's a list of reaction times. And I've got 40 of them, but they're all kind of the same thing. The difference would be a tuple might be if you wanted to have a data structure that represents several pieces of information about a person, right? So like last week when I was telling you all my personal details, you might want to have a collection of information that contains a person's name, their height, their weight, the amount of money they have. These are all important variables for, judging people, right? So if you wanted to collect a bunch of different types of information, a string for the name, a number for how much money people have, maybe an object for something, like if you wanted to associate someone's toaster with them or something, you could group those all together in a tuple. Now, you can actually have lists of different types of items, and you can have tuples of all the same type of items, but people often use lists for lists of all the same type of thing, and tuples for groups of different things. Does everyone get that distinction? Okay. So it's probably easier to do a demo than explain, but just for posterity, lists, the main difference between these is lists, like we said, are mutable, generally group together similar items, and they are denoted using square brackets, okay? So if you see something in square brackets in Python, it's a list. Tuples are immutable, generally group together different types of items, and are denoted with round brackets, aka parentheses, okay? So that's the main difference, is if you see squared brackets, it's a list. If you see parentheses, it's a tuple. All right, so let's take a break, and then we'll have an extended demo session for the rest of the time today, and go through, make some lists and tuples, explain kind of how they work, and then we will hopefully get some time to go into what I was kind of hoping to start last week, which is building up a psychophysics task that will actually kind of look like a real psychological task at the end, more so than these kind of little examples we've been doing. Okay, so any questions before we break for a couple minutes? So sorry about that issue that we were having, that we were talking about during the break, that all of you were having with actually getting the dumb game demo to work, because I forgot once again, because it works so excellently on my wonderful Macintosh computer, I had forgotten that there is this issue with the lab PCs where if you're doing text-based stuff in the shell, the sound won't work. Sorry about that. If you all replace the death march function, you could go in and you could say, like, instead of this death march function, you could just replace it with, a function that like just says, actually, this might be a good exercise for you guys to do, just for grins. So, you could just replace all this text. You could actually just delete yours. I'm commenting mine out because I might want it later. But, you could just replace this all with, like, print dum, 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 you died, or something like that, Right, so that can be your death march. And now this should actually, and take out these import lines, which are really the ones causing the trouble. And then your dumb game should actually, oops. What is going on here? Apparently I'm having issues too. Did I not save my game functions file with the new? What? All right, that's just crazy. I have no idea why it's not recognizing the changes to the files. That's just weird. I think it's not Halloween this week, right? It was last week, so it's not possessed by demons or anything like that. All right. I have new sympathy for you guys if you encounter weird problems in your problem sets. All right, so Death March now does not make any sound. play my dumb game. Unless I have like another copy of the my dumb game function somewhere that's actually running the wrong version, but I don't think I am. Okay, right, dum-dum-de-dum, you died. Okay, so that version should work for you guys if you take out the actual sound stuff. Okay. So anyway, we're getting away from this anyway in just a minute, but sorry about that if you had issues. Once again, for anyone that was out of the room, we're getting, like, this will seriously be the last time we deal with text input and output this way because it's just too much of a pain to deal with these weird bugs that come up. So in the problem sets, we're going to stick to all CyclePy stuff from now on. Okay, so anyway, the main point I was going to make is just let's play around a little bit with lists and tuples, right? So if you want to make a list of something, it's very easy to do, right? So if you want to have a list, and again, I just use dumb variable names like A and B for examples. So if you want to have a list like 1, 2, 3, 4, 5, you can do that, and A is 1, 2, 3, 4, and 5. And if you wanted to make it a little more interesting, you could say A equals, they don't have to be in order. They could be 3, 5, 1, 7, whatever. And now you have a list like this. And if you want to get just a piece of A, which is often a thing you want to do with the list, the way you do that is you use these brackets again. And what these do is effectively give you, like when we saw those indices with the string, this is what we call them, like the number of the item. So if you look for A number 0, that's 3. A number 1 is 5, and so forth, right? So the idea here is that you put in the number of the item, again, remembering that numbering starts with 0 in Python, not 1. So you put the number of the item in brackets next to the A, and what that means is, it's like a subscript in math if you're used to using those, like A number 0 is the first element, A number 1 is the second element, and so forth, right? So we can make lists like this. And the same thing is true of tuples. And again, like we said, we usually use tuples for more different types of information. So we could say B equals, your name and your current amount of money you have in your wallet, which I think last week was $234. And let's do height in feet and inches because that's a nice floating point number. So that'll be 5 plus 11.0 over 12. And if we put those all in parentheses, then B shows us these three different types of information. My name, the number of ringgit in my wallet, and my height in feet as a floating point value, right? And it shows them all in this little list, which is denoted by round brackets or parentheses rather than square brackets, right? But you use them just the same way. If you want to access just my name, you can do B bracket 0. If you want to do just the number of ringgit in my wallet, B bracket 1, and just my height in feet, B bracket 3. Okay? B bracket 2. That makes sense to everybody, just as a quick sort of thing. So that's just a demonstration of how they work, but let's show you actually how tuples could be useful in a kind of real-life context in this demo. So, like we said, we've got this demo now where it's less code than it was before, right? We've got it down to like 33 lines, but what you can see is there's still a lot of repetition, right? Because what you're basically doing is setting player alive equals to true. Then you have this little if statement where if the player's alive, you say you encounter a dragon, fight, or flee. If answers flee, you say you ran away safely, otherwise you die. Then you do the same exact thing, only changing a couple words, right, as to what you encounter. But the logic is all the same. So what would be a better way to do this? If you could, like, what would you use to kind of reduce the number of lines of code that we do this with? Well, you actually have two options, but they're very similar options. So if I want to basically do the same thing several times, what would I use? Give you a hint. One starts with F and one starts with W. Well, okay, so you could do a function, But actually, I was thinking of something else. It's something that we talked about very early in the class. Loops, right? Somebody said loops. So, right, so we could use either a for loop or a while loop, right? Because what we really want to do is we want to do basically the same thing like 3 times, and the only thing we want to change each time through is whether it's a dragon, an orc, or an angry lecturer that you encounter and have to fight, right? So let's think about how we might change this. And again, this is sort of stretching what you've already done before, but hopefully you'll see actually now why it's kind of useful to have these loops, right? Because you can do sort of sophisticated things when you package loops together with things like lists and tuples. So what we're going to do actually is let's first make a variable that is a list of enemies that we're going to face, okay? Or actually, we'll do a tuple. It doesn't really matter, but we don't need to change this this list or this tuple. So since tuples tend to be, or since tuples are immutable, we may as well use a tuple here because we're not going to change it. Let's say our enemies are going to be a dragon, comma, an orc, comma, or one of the lecturers early in the morning before they have had their coffee. Right? All right, so if we surround those in parentheses, or again, round brackets if you use the British nomenclature, what we've created then is a list of enemies, right? Well, a lot of us have made a list of enemies in our lives, but now we are literally we're making a tuple of enemies, right? So, so you make a tuple of enemies, and if you wanted to see that in action, we could even try it out down here, right? And we can see, okay, our enemies are a dragon, an orc, and one of the lecturers. And what we're going to do in just a second, you'll see, just to preview it, is we're going to be able to access individual ones of these, right? Okay, so we have a tuple of enemies now. And what we're really going to want to do is we're going to want to we'll take out 2 of these instances of doing this code, right? Because we're just repeating the code 3 times. What we really want to do is have a for loop that loops 3 times and just refers to a different enemy each time, right? So what we can do is we can create a for loop called, so this is actually doing something that you haven't done before, all right? So one way that you've done a for loop before is you've said something like we'll say something like current enemy in range 3, right? Now, and I'll go ahead and tab these out because all this stuff is going to go into the for loop, right? So you guys have done for loops like this before, right? Where what this does is range 3, as you've seen before, means do something 3 times, right? And current enemy would be the name of our variable. It stores the number of the time through the loop that we're currently on, right? Now, one thing that we haven't talked about before that we're now going to sort of reveal how this actually works is, you notice that I'm using range here, even though I told you guys in one of the problem sets we're going to mostly use X range. And that's because if you remember that problem set answer, in general it's better to use X range, but for illustration purposes it's better to use just range here. When you just do range 3, for example, in the shell, what does that give you? I mean, it gives you 0, 1, 2, but what is 0, 1, 2 in this case? Well, it's surrounded by square brackets, so that makes it a what? List, right? So before in the problem set, I think everyone got this more or less right. You said, that the reason people on the internet say it's better to use X range than range is because range creates the whole list when you say range 3. So, if we were saying range 1,000, if we were going through 1,000 enemies in this game, it creates this whole list of numbers, right? And, if you were going through 1,000,000 enemies or something like that, that's going to use up a lot of memory for no good reason, when you could just generate the numbers one at a time, right? But the point is, the range function, if you say range, say 5, it creates a list, which is the numbers 0 through 4, right? Okay, so one thing we could do is create a variable called current enemy in the range 3. That would go 3 times through the loop and somehow get what the current enemy is. Well, actually, let's do it that way, and then I'll show you an even better way to do it, okay? So let's actually change this to current enemy num or something like that to indicate that it's the number of the current enemy, okay? And all we're really going to want to do is here where it says you encounter a dragon, we're going to want to change the dragon to one of the 3 enemies in our tuple, okay? So the way we're going to do that, let's create a variable called something like current enemy name and set that equal to one of the members of the enemy's tuple and the, bracket, not parentheses. And we're going to set it to whatever the current enemy num is. All right, so just to explain what happens in this line of code again. So what's going to happen is we're going to run this for loop. It's going to go through the range 0, 1, 2, right? So the first time through, current enemy num is going to be 0. Current enemy name is going to be enemies bracket 0, which means the first thing, the dragon. And then what we're going to want to do is just replace the phrase a dragon. Whoops. Well, actually, let's break this into 2 steps. Let's say, my string equals, take this string that we had, and say you encounter placeholder, fight or flee, and then we use our old friend .format. Remember how we said you don't have to put a number in here? Well, now we're going to put a string in here and put our current enemy name in the place of that placeholder, right? So my string is going to equal this string with its 0 placeholder replaced with the current enemy name. All right, so then we're just going to do raw input with the prompt being my string. And in theory, we should now have a game that works. So let's try this out. Now, for you guys, this should actually also work if you've taken out the sound stuff. So if we try exec file my dumb game.py. Oops, I've got a syntax error. All right, so, what did I forget? I think you say colon. I hope you said colon because that's the right answer. So the reason I'm always forgetting colons is because you'll find that MATLAB and other programming languages don't usually use them there. So it's sort of a weird piece of Python. All right, so you encounter a dragon, fight or flee. Well, just for the sake of going through the list, let's flee. You ran away safely. You encounter an orc, fight or flee. Flee. You ran away safely. You encounter one of the lecturers early in the morning. I missed an M. Before they've had their coffee. Fight or flee. Let's fight the lecturer. Dum, you died. All right. So that's all well and good. Let's fix that there. Okay. So do you see how that kind of goes through the list? So what we're doing is we go through the range. And actually, if you want to make this more explicit, we could do something like this. Let's say something like status string equals battle number placeholder format current enemy num. And then we can say print status. So if you wanted to see exactly how this is working, run this. Battle number 0, you encounter a dragon, fight or flee. Flee. Battle number 1, you encounter an orc, fight or flee. Flee. Battle number 2, you encounter the lecturer, flee. Yay, you beat the game. Okay, so what you can see here is, as we're going through the for loop, current enemy num, as you've seen in other for loops you've written, takes in the values 0, 1, and 2 in turn. We make this status string that says battle number something and replace it with the current enemy number and print it out. Then we print the prompt for the battle, get our answer in raw input, see if it's flee. If so, say you ran away safely and keep the person alive. Otherwise, play the death march and set player alive equals to false. And at the end, if they're still alive, say congratulations, and otherwise you say they're dead. Now we've got, even like a slightly more complex game than we had before, and we've cut it down to only 24 lines of code, right? So we're increasing the complexity of our game while decreasing the complexity of the code, right? Which is always good because it makes it easier for you to read your code, and the less code you actually have, the fewer bugs you're going to have, right? And the easier it's going to be to find them. So this is all good to reduce the amount of code you're actually dealing with. Okay, so what I'm going to do now, because this is not part of the current plan to put that battle number in there. So let's say we don't care about displaying the battle number. Let's say we only care about keeping track of the current enemy. We can actually simplify this even more. So this is what's going to give you a peek under the or behind the curtain of what the for loop is actually doing. So we don't actually need to number the enemies and use this range function at all. We can actually just say, so we can actually get rid of this line entirely where we access the current enemy name. And we can actually set the current enemy name directly in the for loop. And instead of using the range function at all, right, so this is your first time using a for loop without the range function, you can actually just say for current enemy name in enemies. And if you delete that and paste the running thing here, you encounter a dragon, fight or flee, flee. You encounter an orc, fight or flee, flee. You encounter a lecturer, flee, yeah. So this works exactly the same way. And it hopefully shows you a little bit more about what this for loop is doing that you've been using all along. So the idea here is, what if, when you have this for in syntax, okay, what you're actually doing, what you've been doing all along, but now maybe you can see what you're actually doing, is what you're really saying is, here's a variable. Every time you go through the for loop, set that variable to the next item in whatever list or tuple this is, right? So this can be either a list or a tuple. And what it's saying is for, and it's just a little bit funky way of saying it, but basically you're saying for every item in the enemies list, go through that list and set the current item to whatever this variable is called. Does that make sense to you guys? So a common way to do a for loop, of course, is to use the range or the xrange function to make a list, of numbers that you go through. Because if you want to go through something 100 times, you just go through the numbers 0 to 99, and that's 100 things. But if you don't want to necessarily go a certain number of times, you want to work your way through a list or a tuple of things, you can do it this way and eliminate that sort of numeric counter variable entirely. Does that make sense to you guys? Kind of? All right, so now we took out that battle number line because that wasn't part of the original game anyway. But now we're down to actually just 21 lines, so we've eliminated even more. And really the top couple lines of code are just kind of junk I have to do to get around some PsychoPy bugs. So effectively we've got under 20 lines of code for this admittedly kind of stupid game, right? All right, so questions? Are people having any issues that they want to ask about? Do we need to take a quick debug and answer issues or questions break? But again, that's the heart of programming, is you spend all day trying to figure out why your reasoning is wrong, and then you find out you didn't type one letter somewhere. Okay, so any other questions or issues? All right, so again, the main points here are just to see a little bit about how lists and tuples work, how you create them, right? So it's easy to create them to just say enemies equals parentheses and then three things. I didn't explicitly say this, but of course you separate the three things with commas, just like you do in a list in English, right? So a dragon, comma, an orc, comma, or half stop, I suppose if you're English, and the other thing, and then you enclose them in parentheses if you want a tuple, or square brackets if you want a list, right? And actually, if you want to just test this, you can see that it doesn't really matter whether you use a list or a tuple in this context. It's really just a question of style. So it'll work exactly the same way if you use a list instead of a tuple. Okay? All right, so everybody good so far? All right, I think it's time for us to officially bid farewell to the shell tab, because it's really been nothing but trouble to do these simple text games and so forth. But I would like to note, so yeah, we got down our game to about 21 seeing I actually had 20 lines of code in my old version. I don't know where I saved a line of code in that one, but anyway, so oh yeah, I just didn't have one of these empty spaces. Yeah, so we're down to about 20 lines of code from 130, right? Which makes life much, much easier. If you add a little bit of, you're adding a little bit of syntactic complexity to your code instead of just doing this dumb copying and pasting. But ultimately, you're making the structure of your program much better and much easier to read and much easier to modify, right? Okay, so with the time we've got left, we've got about 15 minutes. We're going to just start putting together everything we know so far into something that resembles a real psychophysics task. And we may not get through all of it, but some of this will be kind of a refresher, and we'll kind of pick up with this again next week. So what we're going to do is let's make a new file called like psychophys demo or something like that. .py, and make a new file. We can call this something like, this is going to be our functions file that our psychophys demo file relies on, so let's call this like psychophys.funcs.py or something like that, right? Because again, it's nice to separate where your functions live from where the main code lives, just so you can, once you get the functions right, you can kind of put them away and forget about them. So before we do anything else, what we're probably going to have at the top of our main psychophysics demo is from psychophys funcs import star. So, right, because we do that every time we import functions. Now, what we'll start with, so a lot of this code we can actually steal from previous versions of tasks that we've done in PsychoPy, right? So if we want, we could go to like the number guessing demo. Maybe I'll open that up and I'll steal a bunch of code from it. So, all right, so one thing we're probably going to want to steal is the settings, part of the settings section, right? Because we're definitely going to want to set our display resolution like we usually do. Now, this is another little thing that we've been doing all along that hopefully makes sense to you now. What is display resolution? When we've been doing this before, I mean, you know that we're setting our display resolution to 1024 by 768, but what is that variable type? So it's square brackets, so it's a list, right? Oh, yep, list, not tuple, yep. But they're totally confusable, and actually, it's worth mentioning, they are so confusable that I didn't bother to check the documentation very closely when I first wrote this. The function that you give the resolution to, the window function, it actually wants a tuple instead of a list. We've been using a list all along, but it actually does want a tuple, so we could change it to a tuple if we want. But like I said, 90% of the time it really is not going to matter which one you use. It's just really a matter of good style. And for you guys, some good style is nice, but I'm not worrying about it too much at this point. All right, so we're going to do a task. The task I'd like to do is a psychophysics test where you have to judge between two stimuli, and what we judge we can actually change. But like, let's say we're judging the difference between the pitches of two tones is what I was going to start with. So, again, if you remember your psychophysics stuff from like last year or whenever, the whole idea, right, is we have thresholds that we can detect, right? So you may be able to detect a 10 hertz change in frequency of two tones, but you may not be able to detect a 0.1 hertz difference in frequency, right? So we can actually write a task to determine what the threshold of your ability to determine differences in pitch is by basically creating a bunch of pitches and that are either the same two pitches or different pitches, and presenting them both and seeing if you can tell the difference between them. Okay, so we're going to want to define a few settings up top. So let's say we're going to have one called in trials. That'll represent the number of trials, and for now, let's keep it to like 5 because we want it to be short. Of course, in real life, you might want to do 50 trials or 100 trials or something. And let's set our minimum hertz, meaning like the lowest frequency of the tone that we care about. Let's say that's going to be like 200, and let's say the max hertz is going to be something like 2000, okay? I just picked these because they're good frequencies. We're going to start off with a fairly dumb version of the psychophysics function and then get smarter. So we'll see how it goes from here. So instructions text. So we'll probably want to put some instructions up on the screen. So again, I'm going to start doing this thing that we've already been doing where we kind of take all of our important stuff that might change from task to task and put it up at the top so we can easily change it. So let's say we're going to have 2 screens of instructions, and like instructions screen 1 text is, I am going to play some pairs of tones. New line, new line. I think you guys have seen the new lines before. Your task is to tell me if they are the same or different, same or different pitch. New line, new line. Parentheses, press any key to continue. So that'll be the first screen of instructions. So nothing too crazy here, right? We're just creating a string. And then we'll probably want another screen of instructions. And let's say this one is press the S key if the tones are the same. Press the D key if they are different. New line, new line. Press any key to continue. Oops, parentheses, period. Okay. And on each probe of the task, or when we ask them, we might want to put some text up like, we might want to say something like, same or different, just to remind them of the keys. S or D in parentheses, just to remind them what to hit. Okay, so we sort of defined all of our major, just our major parameters or preferences or settings or whatever you want to call them for the task, right? So that we've got all up here. Pretty much everything else we can put into code. And I know we only have like 7 minutes left, but I'd like to at least type out the code and show it working, and then we can like sort of tweak and play with it a little bit more next week. All right, so this part's going to be pretty much the same as what we've done before, but hopefully this stuff is getting more and more familiar to you. So we'll take this line about how there's no more user settings, and we'll take our window creation line, just copy and paste that. So we have scipy.visual.window, display resolution, full screen is true, units is pixels, allow GUI is false. Most of those should make sense to you at this point now. You don't need to really worry about what allow GUI is. Just know that it should be false. Okay, and let's actually, at this point, we kind of did this before, right? I think we had our helper functions last time, right? So, okay. So, do you guys remember if we had this helper functions.py that we created, what was this, a couple weeks ago or last week? A function to present a string and wait for a key press. Does everyone remember creating that helper function? I think we actually, where's the, let's see. We do a similar one in, this is where I shouldn't have used these dumb function names. Okay, yeah. No, I guess this was 2 weeks ago, right? So we created this function, if you remember, called prompt key press. And let's put this in psychophys funcs.py. So remember, this was a function, and we had all these nice comments just to tell us how to use it. And remember, we wrote a function that takes in a window object, a string, and optionally takes the name of a font, font size, and width. Oh, we actually used this on the problem set, right? You guys used something like this on the problem set? So this should be familiar to you. And it draws the string that you specify and waits for a key press and returns the key press back to the function, right? So we can, again, this is the beauty of reusing code, right? So we reuse this code, and our instructions is just going to be, right, if we want to present the instructions to the participant, prompt key press. So we call the prompt key press function, give it my window that we just created, And we want to say, what's the next thing it wants? The next thing it wants is a string. So the string is going to be instructions 1 text. And again, if we wanted to make it super clear, we see that the names of, so we're giving it the window and the string. We're going to let it use everything else as the default arguments. But if we want to be super clear about what's what, we could actually say window equals my window and string equals instructions 1 text, right? So hopefully if you guys made it through the problem set, you should realize that adding in those two things makes it run exactly the same way. It just makes it a little bit more clear that we're specifying the window and string parameters of the prompt key press function. And then if we want to present the second instructions text, we just do the same line with instructions 2 text. And let's actually just run that and see how that goes. Let's see how far we get with that. Oh, so we have an error. Name PsychoPy is not defined. Oh, okay. So what did I not do? Anybody see what I did not yet do? It's on the visual.window. So what I didn't do yet is import PsychoPy, right? Because I'm using psychopy.visual, so I need to import psychopy.visual functions. So let's see if that runs now. Oops. Prompt key press is not defined. Uh-oh. Yours works and mine. Def prompt key press. What if this is our standard issue with having to just restart and run it over again? Oh, maybe I just didn't have one saved or something. That's weird. Okay, so I'm going to play some pairs of tones. Your task is to tell me if they're the same or different pitch. Press any key to continue. Press the S key if the tones are the same. Press the D key if they are different. Press any key to continue. Okay, so that's pretty good. That shows our instructions. So one thing I will do before we quit, because we won't have time to actually put the code for the actual task in, is let's say you have a task where you have like 100 screens of instructions. I don't recommend you do this, but let's say you did. One thing that might be nice is you might want to make your task work with any number of screens of instructions, right? So if we wanted to do that, we could actually make a tuple with the list of all our instructions on it. So we could say like instructions tuple or something like that. And we could say that that's going to be instructions 1 text followed by instructions 2 text, right? And maybe actually if we want to drive the point home, we can make an instructions 3 text instructions 3 text equals, let's say, do your best. Here we go. All right, and then you could add that to the tuple. And then what we could actually do, if we want, is we could even though we've only got 2 lines here, it's somewhat better code style. If you've got multiple things to do, it's somewhat better to loop it than to just paste it multiple times. So we could say for instructions, let's just abbreviate it to be quick, text in instructions tuple colon prompt key press. We only need to do it once now. And the string is now going to be instr text, right? And if that runs, in theory, it'll give us now 3 screens of instructions. There's 1, 2, 3, just like that, okay? So there's putting our tuples to good, putting both our tuples and our functions to good use. Okay, so I know we went pretty quick creating this demo because really we're just trying to get the, like sort of the backbone of the demo in place. Because what we're really going to do is then tweak this over the next few weeks and make a full task out of it with a lot of different components. But I wanted to get sort of the basic part in place and show you an example of where you might use a tuple to make your code slightly more efficient. So there's an example. So any major issues or questions or anything that might want to be recorded for posterity before we wrap up? Okay. So thank you. I'll stick around afterwards for, if you have unofficial questions and so forth.